Hello everyone and welcome. Today we're going to resolve LeetCode daily problem number 2071. Maximum number of tasks you can assign. So it's a hard problem which will require a lot of thinking and explanation. So in description we have m tasks and m workers. Each task has a strange requirement stored in their indexes integer array tasks with the ith task requirement tasks I strange to complete. The string of each worker is stored in a zero indexes integer array workers with the jth worker having workers index j strange. Each worker can only be assigned to a single task and must have a strange greater than or equal to the task strange requirement. So worker j should be bigger or equal than tasks I. Additionally, we have pills, magical pills that will increase a worker's strength by strength. You can decide which worker receives the magic pills. However, you may only give each worker at most one magic pill. So we give the index integer arrays tasks and workers and integer pills and strength. We should return maximum number of tasks that can be completed. So we have few examples, like example 1 where task 321, worker 033, pills 1, strength 1. So from here we go in explanation that we have output 3. Each task will be completed because we can assign the magical pill and task the follow. So we have worker 0, so their strength 0 and they cannot complete any task of this list. But we have pills 1 and strength of 1. So when we assign to the worker 0 magical pill, we get strength 1, which be equal to our task 1, and worker 0 will be able to complete the task index 2, number 1, individual 1. Then we can assign worker 1, it has strength 3, to any of the following tasks from 0 and 1. So we assign here to the second number, and 3 more than equal 2, it's completed. Then we have assigned second worker, and index second is our third worker, to the task 0, to the first other task, and 3 equal 3, that is fine. So we completed. Then we have task 5 and 4, and workers 0, 0, and 0. We have pills 1 and strength 5. So from this description we already understand that output will be 1 because any of these workers, none of them cannot complete any of this task without magical pills, and we have only one pill. Therefore, any worker we took, we can increment them and allow them complete a task, because 5 will be equal to 5, it will be more than 4. Quite a lot of explanation, but let's think about more like in story way. So in the bustling city of Procrastination, tasks piled up like frogs on a log. Mayor Lily, inspired by Eating That Frog by Brian Tracy, challenged her team to tackle the toughest chores first and avoid wasting time on small ones. She lined up her tasks from easiest to hardest and called upon her stronger workers. But some workers needed a magical pill, both to leap the task in a single bound. To maximize completed chores, they tested different team sizes. First, they tried sending a small crew. If they could conquer the hardest tasks, boosting when needed, they invite more helpers. If not, they scale back. Through this binary search on team size and greedy matching routine, reversing boosted workers in a queue, they hit the sweet spot, the largest K, for which every task had a capable worker, Mary Lily's team learned that by eating the biggest frog first and by systematically testing their capacity, they could clean the swamp in record time. So, as you understand from this little story, we will use binary search with greedy matching. We'll will use sorting and dequeue to implement that. Time complexity generally and space complexity in worst case scenario will be both of big O of n. If we dive deeper, it will be big of n plus m, when it will also sorting plus binary search integration of OK checks. And for space complexity, it's also be O n plus m sorting plus OK for the dequeue worst case scenario. So as we understand, we will start by sorting our tasks. Then we will need to sort our workers, but we make it in reverse order. The idea here to get the stronger workers first and the smallest task first. After that, we will define a function can assign, where we have key of integer, and we will return boolean value. We will need a few variables. So first will be worker index will be equal to 0. Remaining pills will be equal to pills. We will need pill candidate. Pill candidates will be equal to the queue. So this queue will be used for workers that waiting for pill bust. So when we use, we will remove them from the queue, as each worker has only one bust. Then we will try to match the key hardest tasks. So for task index in reverse order, minus 1, minus 1. We'll make a requirement for either where will be task and in this task index. So first step will be to directly match stronger and used worker to the task. So for example, if not candidates and workers worker index equal bigger than our requirements, then worker index will be incremented by 1, which means we complete the test and continue. The next step will be use reverse boost candidates without consuming a new pill. So here, if pill candidates and pill candidates and 0 equal bigger our rec, then pill candidates will be pop left, which means removed, and continue. Then we will queue all workers who can meet requirements after taking a pill, so they will able to complete a task with help. So while worker index less than k and worker index plus strange bigger equal requirement. We will use pill candidates append workers at workers index, and worker index will be incremented by 1. Lastly, we will use one pill on the best reserved candidate. So if pill candidates and remaining pills bigger than 0, then pill candidates pop remove, and remaining pills will be subtracted by 1. Now we can return our false if we cannot assign this task, and then we return true if all k tasks are assigned. Now will be a step of our binary search for maximum k. So we will start with left and right, where left will be equal 0 and right will be equal minimum len task len workers. Then best will be equal 0, and while left equal to the right or less than right. Then we will look for middle for our binary search, look plus right and divided by 2. So we will use this previous function can assign on middle and make simple logic. If best equal left equal mid plus 1, else right will equal to mid minus 1. And we return our best. Pretty complicated logic of binary search with greedy tree, but it's all passed. Oh, I will add slightly algorithms on the top. Algorithms, so it will be binary search with greedy. So we have 2 algorithms, and general for data structure we use sorted lists and we use the queue. And lastly, time and complexity in the worst case scenario will be big of n for both. So let's submit this code. And it's very efficient, which means that we should start with the most tedious tasks the first thing in the morning. So eat the most ugliest, the biggest fraud that you can find, and everything will be fine. So thank you for your attention. Have a nice day. Bye.